Have you ever felt like real-time communication is hard? It shouldn't be. Today we will build a cool collaborative drawing experience with Flutter and Serverpod. We call it Pixorama. Let's look at the final app before we start. Pixorama is inspired by rplace on Reddit. It's an app where anyone can place pixels on a grid and draw an image together. So, here I have two instances of Pixorama running. When I draw a pixel in the app on the left side, you can see that it also updates the app to the right. This works because every time we draw a pixel, we send a message to the server, which passes it on to any other connected app. My name is Victor. I used to work on the Flutter team, and now I'm the founder of Serverpod. Serverpod is the missing server for Flutter. It's an open source, scalable backend written in Dart for the Flutter ecosystem. Subscribe to this channel for more tutorials and tips on building your backend in Dart. In a traditional REST API, you send messages to a server and receive a response. When communicating in real time, we also need a way to send data from the server to the client. The most common way to do this is using WebSockets. They work by opening up a connection to the server, but instead of closing the connection when we receive a response, the connection is kept open. This way, the server can keep sending multiple messages back to the client. Working with WebSockets poses several challenges. We must figure out how to serialize data and handle the connection lifecycle. Luckily for us, Serverpod makes all this easy. Serverpod 2.1 introduced a feature called streaming methods. This means that we can return a stream from a method on the server and call it from our app. Serverpod will generate the full protocol for us and handle the underlying WebSocket connection. Let's start building. First, we need to create a new project. We do this by running the Serverpod create command. Since we're not planning to store any data in the database, we can use the mini version of Serverpod. Serverpod Mini is a simpler version of Serverpod without a database, advanced logging, and some other features. It still has everything we need to build our API and to stream data. We create the project by running serverpod create pixorama --mini. Let's open it in VS Code and see what we have. Our server code is in the Pixorama server package. We start by creating our models, which are classes that we can serialize and pass to and from our server. We place our models in the libsource models directory. First, we remove the example model as we will not need it. We are going to create two new models. The first one we call image data. This model contains a full picture we will send to the app when it connects to the server. We have the image's pixels saved as byte data, which is basically a list of bytes where each byte represents a pixel in the image. Then we also define the width and height of the image. The length of the byte data will be the width multiplied by the height. Next, we need a way to represent a changed pixel. Let's create a second model called ImageUpdate. It will have two fields, the index of the pixel in our array of bytes and the new color value. We will draw our pixels in different colors depending on the value of the byte representing the pixel. Cool, we got our models down. Before we can use them in our code, we need to run serverpod generate. This will create the actual Dart files of our models. Now, let's look at how we can build the server itself. We will need to create a new endpoint for this. Endpoints in Serverpod are the connection points our client can connect to. We find the endpoints in the libsource endpoints directory. We delete the example endpoint and create a new Pixorama endpoint. All endpoints in Serverpod should extend the endpoint class. We're going to start by defining a couple of constants. We define the image width and height. The number of pixels is the width multiplied by the height. We define the number of colors we will use in our palette. Let's stick to 16 colors, which means that valid values in our individual pixels are any number between 0 and 15. We also pick a default color. Next, we need a way to represent our pixel data. We will use a uint8 list for this. We create a new uint8 list and fill it with the default color. This representation of the image will be shared between all clients as we only have one instance of the Pixorama endpoint. Let's explore the core magic of the endpoint. How will we pass the image data to our clients and keep them updated on the latest changes? ServerPod comes with a built-in messaging system called Message Central. These types of systems are often referred to as PubSub. We can publish and subscribe to events. To do this in ServerPod, we can use named channels. Let's define a name for our channel. We call it Pixel Added. Now, what happens when one of our users draws a pixel? Let's create a method for that and call it setPixel. In ServerPod, the first parameter of an endpoint method must be a session object. The session contains information about the call and gives us access to features like Message Central. We also pass in the new color of the pixel and the index of the pixel in the image. It is always good practice to verify that the values passed to our method are valid. ServerPod already ensures that all parameters are passed as the right type and checks for null safety. But we want to avoid passing on any invalid values to other clients. First, let's check that the color index is in a valid range. It needs to be larger than 0 and less than the number of colors in the palette. Next, we're adding a check for the pixel index so that it's not outside the scope of our image's pixels. If any of the values are out of range, we throw a format exception. This will abort a call and throw an exception in our app. Now that we know our input parameters are valid, we can update our image by setting a pixel in our pixel data. Finally, we need a way to pass this information on to other connected clients. We'll use ServerPod's Message Central for this. We access the Message Central through our session's Messages field. Then we post an image update object to our Pixel Added channel. We can post any of our models through Message Central, and if anyone listens to the specified channel, they will receive the messages. The final part of our server that we need to write is a way to update our clients about the added pixels. Let's create a method called ImageUpdates. The ImageUpdates method will return a stream. This allows us to send multiple updates to any client that calls this method. If we declare our method async star, we can return values using the yield keyword. First, we need access to the messages we post when a user sets a pixel. We can subscribe to the messages by creating a stream for the Pixel Added channel by calling the createStream method. Once we have access to the stream of updates, we can pass the full image to the client. By creating the stream before doing this, we ensure that we won't miss any image updates. We send the image over by yielding an image data object. The image data contains the pixels of our image and its width and height. Finally, we need to pass the messages from our Pixel Added channel on to the client. We do this by listening to the update stream we created at the beginning of our method and yielding the values to our client. The easiest way to listen to the updates is to use the awaitFor construct. To make all the updates we have made to our server accessible in our app, we need to run ServerPod generate. ServerPod will then analyze our server code and recreate the methods in our client. That's really everything we need for the server side of Pixorama. It's less than a page of code. How cool is that? Next, let's build a Flutter app. When we created our project, ServerPod set up a Flutter app for us. The app just has a main file with a very simple example. Here, let's rename the app to Pixorama app. We remove all the demo code and create a scaffold that has a Pixorama widget as its child. Now, let's build a Pixorama widget. We make it stateful. To draw the actual pixel image, we use the pixel editor from the Pixels package. Pixel editor uses a pixel image controller, so let's add a reference to that. In our initState method, we just call a ListenToUpdates method. This method will connect to our server and listen to updates through the ImageUpdates method that we created earlier. The ListenToUpdates method will be asynchronous and will run indefinitely as long as the app is open. Let's look at how we can build a ListenToUpdates method. First, we're adding an infinite loop. We'll try to connect to the server and listen for updates in the loop. If we fail to connect, or if the connection goes down, we will wait 5 seconds, then try again. We'll place the connection code in a try-catch to catch any exception if things go wrong. Inside our try-catch, Let's first get access to a stream from the server. Like any other ServerPod method, we call it through our client object. Once we have a reference to the stream of image updates, we can start listening for updates. The easiest way to do this is with an await for loop. Every time we receive an update from the server, we will run through the body of the await for loop. We can get two types of messages from the server, an image data object or an image update object. The image data contains the full image and is the first message the server sends when we connect. The image update contains information about the changed pixel and its new color index. We can check which type we have received using the is keyword. If we receive an image data, we create a new pixel image controller containing the pixels we just received. We also need to pass the size of the image into the controller and pick a palette to use. Here we use the same palette as rplace. If we receive an image update, we won't need to replace the full image. The only thing we must do is update a single pixel. We do this using the image controller's setPixelIndex method. The final thing we need to do in our loop is to handle any connection errors that may occur when using the stream. This can happen if we fail to connect to the server, if the connection is lost, or if the server shuts down. These scenarios serve different exceptions, but they all inherit from the same base class, the method stream exception. This makes it easy to handle all of them the same way, which is often what we want to do. Let's catch the method stream exception. If the exception is caught, it's because we have lost connection to the server one way or another. Here, we set the image controller to null, indicating that we no longer have an open connection. At the end of the loop, we await a delayed future. This will make us wait 5 seconds before we move on to the start of the loop and attempt to connect to the server again. That's all the logic we need to handle the state of our app and the streaming connection to the server. The final missing part is building our interface and sending any changed pixels to the server so that other connected apps can be updated. We do this in the widget's build method. First, we create a center widget to ensure that our pixel editor is placed in the center of the screen. Next, we check if our image controller has been set. If it has a null value, we haven't received any image yet, so we show a circular progress indicator. If the image controller has a value, we have received an image from the server and are ready to show it to the world. We do this by creating a pixel editor. The pixel editor takes the image controller as an argument. It also has a callback on setPixel, which is called whenever the user clicks a pixel. When a user adds a pixel, we call the setPixel method on our Pixorama endpoint. The setPixel method takes a pixel index and the color index as arguments. Well, that's it. We are ready to try out our brand new Pixorama app. To do this, we first need to start the server. We start the server by changing the directory to Pixorama server, then running dart bin-main.dart. With the server up and running, we can start our Flutter app. Change the directory into Pixorama Flutter and run Flutter run. You can, of course, also run directly through VS Code. We can start a second instance of our app to spice things up. This way, we can see that all the updates we make to one of the apps show up in the other app too. Very cool! This was a short introduction to working with streaming data in Flutter and ServerPod. The full example is available at the link in the description. Follow us for more tutorials about backend development with ServerPod. I hope you got inspired to start building apps with real-time communication. It's easy and fun and can really take your apps to the next level. Till next time, happy coding!